So in this video we're going to talk about the vertex form of a quadratic function. The main things I'd like to talk about is how to find the axis of symmetry as well as the vertex as well as whether it has a minimum or a maximum. For now though, we'll start with the axis of symmetry and the vertex. So with vertex form, the reason why it's called vertex form is it's very easy to find the vertex from vertex form of a quadratic. Your vertex is going to simply be h, comma, k. The coordinate point that is your vertex will simply be h, comma, k. Really, the only thing you need to notice is that in the actual equation you have x minus h, whereas the vertex has a positive h, meaning you basically just need to switch the sign of whatever you see in the equation to what you actually have for the vertex point itself. K does not change. Notice that here k is positive, and it's also a positive k in the coordinate point for the vertex. So k stays exactly the same, but h can just change its sign. This is going back to the same reason why we had to switch the sign whenever we were doing stuff with transformations earlier. So if you've forgotten how that all works and everything, feel free to go back and look at the transformation lesson, because it'd be good to review that as well. Now, axis of symmetry. The idea behind the axis of symmetry is, as you probably know already, a quadratic function is either going to be a U-type shape like this, or it'll be an upside down U type shape like this. That's really the only two types of graphs we're going to have for a quadratic function. And so what we notice here is that for any quadratic, there is a vertical line that the graph is symmetric over. Like here, you can kind of see how there's this vertical line here that either side of the U or upside down U is basically just mirroring over that line. Now, something else you might notice when you look at this this dotted line here is that the point where the graph is symmetric, the point that this axis of symmetry is going through on both these would be the vertex of the quadratic. The vertex is always going to be the point that that hypothetical line creating the axis of symmetry is going to be crossing through. Meaning, our axis of symmetry is not really something that you need to find separately from the vertex. The axis of symmetry is simply always x equals h. It is the line, the equation of the line, x equals h, meaning whatever the x coordinate of your vertex was is what your axis of symmetry will be using as the number for its equation. Now, the one important thing to recognize with the axis of symmetry is that I have been saying this whole time it is a hypothetical line that the graph is symmetric over. It is not just a number. Lines are always represented as equations, meaning the axis of symmetry has to be the full equation x equals h. You should not just be taking whatever number h is and writing that. Meaning if our vertex is 2, 3, the axis of symmetry is not 2. It is x equals 2. You have to put the x equals with it. Only other thing I'd want to talk about is a minimum versus a maximum. Basically, the idea is, as we talked about, we've got two different types of graphs here. So if you're looking at the one that opens up, meaning the regular U shape, this graph, well, this graph would not have a maximum point because we can see it is going up forever. But it does have a minimum point because this vertex point right here is the lowest point of the graph. All right, we can clearly see that's as low as the graph goes. So if your graph opens up, you'll have a minimum. Well, the question then is, how do we know if the graph opens up or not? And the answer is we figure that out by the a value. The a value right here. If your a value is greater than 0, meaning if your a value is positive, that means the graph will open up. I'm going to rewrite that because that was not the best handwriting. That means your graph will open up. And so like we said, if the graph opens up, that means you have a minimum point. If, however, you happen to have a graph like the second one, the upside down U shape, where it's opening down, well, that one would not have a minimum point because it's going down forever. Instead, it would have a maximum point because the vertex is the tallest, the highest that the graph goes. If it opens down, that would mean you have an a value that is less than 0, or in other words, it's negative. If you have an a value that's less than 0, that means your graph will open down, causing you to have a maximum point. So for an example, let's take a look at this quadratic here, this quadratic function here. F of x equals 3 times the quantity of x plus 2 squared minus 5. So first thing I want to do probably is determine what the vertex of this line would be. Well, I know my vertex is h comma k. H is going to be the number inside the parentheses with x, that's either adding or subtracting to it, and k will be the number outside of the parentheses that's either adding or subtracting to that entire quantity. But I do remember that I need to switch the sign of my h value. So I can see that that 2 is representing the h value. It's in the h value spot. But for my actual vertex, it will be a negative 2, so we have to flip that sign. Whereas outside the parentheses, I have a minus 5. I'm really going to keep that sign exactly the same. You do not change the sign for your k value, it's only the h value that you need to flip the sign. So if I've determined that my vertex is negative 2, negative 5, well, then that means my axis of symmetry, which I know is the equation of a line and therefore has to be x equals, I guess even more specifically I should say equation of a vertical line, it will be x equals negative 2 because that is the h value of my vertex, and the axis of symmetry is always the equation x equals the h value. Finally, I'd want to determine if this graph, or if this function has a minimum or a maximum value, meaning I need to determine if this opens up or opens down. Well, my a value here is a positive 3, and so because a is positive, meaning it is greater than 0, that means this graph will open up. And if this graph opens up, that implies that we will have a minimum point. I don't know how to spell minimum apparently.